Welcome to yet another AI Talks with Chris and Nita. Less than 48 hours to the new year. How's it going for you?
I'm super excited about 2025 for a lot of reasons.
I can certainly say the same. You know, with all the buzz around AI these days, there's this one concept that's really at the heart of it all, supervised learning. It's like the engine driving a lot of the AI applications we see and use every day.
You're absolutely right. It's the foundation for many AI systems, and it's surprisingly similar to how we humans learn.
Okay, I'm intrigued. So for our listeners who are new to this whole AI world, how would you explain supervised learning in simple terms?
Imagine you're teaching a child to recognize different fruits. You show them an apple and say, this is an apple. Then you show them a banana, this is a banana, and so on. You're giving them labeled examples, input with the correct output.
Okay.
Supervised learning is essentially doing the same thing with AI, just on a much larger scale and with more complex data.
So we're feeding the AI system tons of data, like images of fruits with labels telling it what each fruit is.
Exactly, that's the training data. And just like a child learns to distinguish between fruits based on their features, shape, color, size, the AI system analyzes the data and learns to identify patterns and relationships between the input and the output.
So the AI is basically learning by example, just like we do. But how does it actually use this knowledge to make predictions on new data it's never seen before?
That's where the learning part comes in. The AI system uses algorithms, which are like sets of instructions to build a model from the training data. This model captures the patterns and relationships it has learned. Then, when presented with new, unseen data, it applies the model to predict the output.
Let's say we've shown our AI 1,000 pictures of apples and bananas. Now we showed a picture of a fruit it's never seen before, a pear, for example. Can it figure out that it's a pear?
That's the goal. If the AI has learned the underlying patterns of what makes a fruit an apple, a banana, or any other fruit in the training data, it can generalize that knowledge to new, similar examples. It might not be perfect, but it's constantly learning and improving with more data.
This is fascinating. It's like teaching the AI to think for itself, to recognize patterns, and make decisions based on what it's learned.
Precisely. And that's what makes supervised learning so powerful. It's used in everything from spam filtering and image recognition to predicting loan defaults and even diagnosing diseases.
Okay, so now I'm starting to see the bigger picture. We're not just talking about identifying fruits here. This has huge implications for so many different fields.
Absolutely. Think about it, that spam filter you probably use every day is powered by supervised learning. It's learned to identify spam emails based on patterns in the sender, subject line, content, and other features.
Wow, I never really thought about it that way. It's amazing how this technology is working behind the scenes in so many aspects of our lives.
And as we gather more data and develop more sophisticated algorithms, the possibilities become even more exciting.
So let's dive a bit deeper into those algorithms. I've heard terms like linear regression, decision trees, and neural networks thrown around. Can you break down what these different types of algorithms are all about?
Absolutely. Within supervised learning, we have different categories of algorithms based on the type of output we're aiming for. For instance, if we're predicting a numerical value, like the price of a house or the temperature tomorrow, we'd use regression algorithms. Linear regression is a classic example. It's like trying to draw a straight line that best fits a set of data points.
So if we have data on house prices and their various features like size, location, and number of bedrooms, linear regression can help us predict the price of a new house based on those features.
Exactly. But what if we're trying to categorize something, like whether an email is spam or not, or whether a customer is likely to buy a product? In that case, we'd use classification algorithms.
Okay, so classification is about sorting things into categories, while regression is about predicting a specific number on a scale.
Precisely. And within these categories, you have a wide range of algorithms, each with its own strengths and weaknesses depending on the problem at hand. Decision trees, for instance, are like flowcharts, where each decision branches out based on a specific feature leading to a final prediction.
So if we're trying to diagnose a disease based on symptoms, a decision tree might ask a series of questions like, does the patient have a fever? Is there a cough? And so on, leading to a possible diagnosis.
Exactly. They're very intuitive and easy to visualize, which makes them popular for certain applications. And then you have more complex algorithms like neural networks, inspired by the human brain. They're particularly good at handling complex patterns and are behind some of the most impressive AI applications we see today, like image recognition and natural language processing.
This is all starting to make sense. So we have different algorithms for different tasks, and the key is to choose the right tool for the job. Just like a carpenter wouldn't use a hammer to screw in a light bulb.
A perfect analogy. Selecting the right algorithm is a crucial step in building a successful supervised learning model.
Okay, this has been incredibly insightful. So we've covered the basics of supervised learning, its applications, and the different types of algorithms. But I'm sure our listeners are now wondering, what does it actually take to build one of these models in practice? What are the steps involved?
It's a multi-step process, but let's break it down. It all starts with data.
Of course, data is the fuel for AI.
Exactly. Think of it as gathering the ingredients for a delicious meal. You need the right ingredients in the right quantities for your recipe to work. In supervised learning, this means collecting a large and diverse data set that accurately represents the problem we're trying to solve.
So if we're building a spam filter, we'd need a massive data set of emails, some labeled as spam and others as not spam, right?
Precisely. And the quality of the data is just as important as the quantity. We need to make sure it's accurate, relevant, and free of biases.
Right, because if we train our AI model on biased data, it's going to make biased predictions. That's a crucial point.
Absolutely. Once we have our data, the next step is pre-processing. This is where we clean and prepare the data, making sure it's in a format that our algorithms can understand. This might involve handling missing values, removing duplicates, and converting data types.
So it's like washing, chopping, and measuring the ingredients before we start cooking.
A perfect analogy. We need to get our data prepped and ready to be fed into the AI model. Then comes the exciting part, choosing the right algorithm.
We talked about some of the different types of algorithms earlier. How do we decide which one is best for our specific problem?
It depends on several factors, including the type of data we have, the nature of the problem, and the desired outcome. For example, if we're dealing with a classification problem with a clear separation between categories, a support vector machine might be a good choice. But if the relationships in the data are more complex and nuanced, a neural network might be a better fit.
So there's no one-size-fits-all algorithm. It's all about selecting the right tool for the job.
Exactly. And sometimes it involves trial and error. We might experiment with different algorithms and compare their performance to see which one works best for our particular data set and task.
Once we've chosen our algorithm, what happens next?
It's time to train the model. This is where we feed our pre-processed data to the chosen algorithm and let it learn. The algorithm adjusts its internal parameters to find the best possible representation of the relationships within the data. Think of it as the algorithm trying to fit the data points as closely as possible.
So it's like the algorithm is learning the recipe from the ingredients.
Exactly. The goal is to create a model that can generalize well to new unseen data. This means that the model should be able to accurately predict the output, even for data it hasn't encountered during training.
How do we know if our model is doing a good job of generalizing?
That's where evaluation comes in. We split our data into two sets, a training set and a test set. We use the training set to train the model, and then we use the test set, which the model has never seen before, to evaluate its performance.
It's like testing the recipe on a new batch of ingredients to make sure it works consistently.
Precisely. We use various metrics to measure the model's accuracy, precision, and recall on the test set. If the performance isn't satisfactory, we can go back and tweak the model, maybe by adjusting the algorithm's parameters or trying a different algorithm altogether. This iterative process of training, evaluating, and refining is crucial for building a robust and reliable model.
So it's not just a one-and-done process. It involves a lot of fine-tuning and adjustments along the way.
Absolutely. And this process can be quite time-consuming, especially when dealing with large and complex data sets, but the results can be truly transformative.
Speaking of results, what happens once we have a trained and evaluated model that we're happy with?
That's when we deploy the model. This means integrating it into a real-world application where it can start making predictions and solving problems. For example, our spam filter model would be deployed into an email system where it can automatically classify incoming emails as spam or not spam.
So that's when all the hard work pays off and we see our AI model in action.
Exactly. But even after deployment, the work doesn't stop there. We need to monitor the model's performance over time and make adjustments as needed. The world is constantly changing, and our data and models need to evolve along with it.
This has been a fantastic journey into the world of supervised learning. It's fascinating to see how these seemingly complex concepts are actually rooted in simple ideas of learning by example and using data to make predictions, just like we humans do.
And what's even more exciting is that this is just the tip of the iceberg. As AI continues to advance, we can expect to see even more innovative and transformative applications of supervised learning in the years to come.
So we've talked about the data, the algorithms, the training, and the evaluation. but I think our listeners would love to get a peek behind the curtain. What's it actually like to build one of these supervised learning models in practice?
It's a fascinating process, a blend of art and science. Imagine you're a detective trying to solve a complex case. You gather clues, analyze evidence, and piece together the puzzle. Building a supervised learning model is similar.
Intriguing analogy. So let's walk through the steps. Where do we start our investigation?
First, we need to define the problem clearly. What are we trying to predict? What data do we have available? What are the success criteria?
So it's like setting the scope of our investigation, figuring out what we're looking for and what resources we have.
Exactly. Once we have a clear understanding of the problem, we move on to data exploration and preparation. This involves digging deep into our data set, understanding its structure, identifying patterns, and cleaning and transforming the data as needed.
So it's like examining the crime scene, gathering evidence, and making sure it's in a format that we can analyze.
Precisely. We might use visualization tools to get a better sense of the data, identify outliers, and spot potential relationships between variables. And of course, we need to address any missing values or inconsistencies in the data.
Data cleaning sounds like the less glamorous but essential part of the job.
Absolutely. Garbage in, garbage out, as they say. The quality of our model depends heavily on the quality of the data we feed it.
Okay, data prepped and ready to go. What's next in our model building adventure?
Now it's time to choose our weapon, the algorithm. We need to select the algorithm that's best suited to the problem at hand and the characteristics of our data. This might involve experimenting with different algorithms and comparing their performance.
So it's like a detective selecting the right tools for the job: fingerprints, DNA analysis, or good old-fashioned interrogation.
Exactly. Each algorithm has its strengths and weaknesses, and we need to choose wisely.
Algorithm selected, now it's time to put it to work right.
Right. This is where the training begins. We feed our prepared data to the algorithm and let it learn. The algorithm iteratively adjusts its internal parameters to find the best possible representation of the patterns and relationships within the data.
So the algorithm is like our detective, meticulously piecing together the clues and building a profile of the suspect.
A great analogy. And as the algorithm learns, we monitor its progress, tracking metrics like accuracy and error rate. This helps us understand how well the model is generalizing to unseen data.
So we're constantly checking the detective's work, making sure they're on the right track.
Exactly. And if we're not satisfied with the model's performance, we can go back and tweak things, adjust the algorithm's parameters, try a different algorithm, or even gather more data.
So it's an iterative process, a constant cycle of learning, evaluating, and refining.
Absolutely. Building a successful supervised learning model isn't about finding the perfect solution on the first try. It's about experimentation, learning from mistakes, and continuously improving.
This has been a really insightful look into the practical aspects of building a supervised learning model. It's clear that it requires a lot of thought, effort, and expertise, but the results can be incredibly rewarding.
Absolutely. Seeing a model you've built make accurate predictions and solve real-world problems is an amazing feeling.
And as we wrap up this deep dive into supervised learning, what's your final piece of advice for our listeners who might be inspired to explore this field further?
Don't be intimidated by the complexity. Start with the basics, experiment with different tools and techniques, and most importantly, have fun with it.
Great advice. Well, this has been an incredible journey through the world of supervised learning. We've covered the fundamentals, the algorithms, the applications, and even the practical steps of building a model. I hope our listeners are feeling as inspired as I am by the possibilities of this transformative technology. And to all our listeners, Happy New Year. We'll see you next year.
Happy New Year.